Hello and welcome back to my YouTube channel. My name is Professor Govalla, and today I will be talking to you about the differentiator circuit. And essentially what we want to do is find the V out of t of the circuit given a V in of t. And what we want to do is first define what the differential circuit is. So the definition says that a differentiator is an op-amp circuit whose output is proportional to the rate of change of the input signal. So essentially, if we wanted to find the derivative of a certain signal, a certain input signal, we would use the differential op-amp circuit to do that. And something to note is that the input signal must be alternating in order to pass through the capacitor. And essentially, I made a video on this, so feel free to check that out. But in a capacitor, it essentially allows AC, or alternating current, and it blocks DC or direct current, right? And that's why we need a V in of t that's alternating with time. Okay, in order to solve this, we want to notice a couple of things about a ideal op-amp. And the first is that the voltage at the negative terminal is very proportional to the voltage at the positive terminal. And in this case, the voltage at the positive terminal here is basically 0 volts. So this is also 0 volts. So then this is equated to 0, and this is my equation 1. And we want to notice that the voltage here at the capacitor, Vc of t, is essentially equals to V in of t, or the voltage at its left-hand side, minus the voltage at its right-hand side, which again is 0 volts. So Vc of t is essentially just V in of t. All right, so then that's my second equation. So then now what I'm going to do is I'm going to write a KCL, or Kirchhoff current law, that says the current coming into the node here, V negative, is going to be IC has to equate to IR. All right. So the current going into here has to equal the current coming out of there. So what is IC? So the current across a capacitor, again, I've made a video on this, is going to be the capacitance Cin times the change in voltage Vc of t over time dt, which is then equals to IR is essentially just the voltage across RF, so 0 minus V out over RF. And then essentially we want to now solve for V out, so I'm just going to write it on the right hand side. What I'll do first is I'm going to multiply both sides by minus RF. So this becomes a positive and this cancels out. So therefore I get that V out of t is equated to minus RF Cin. The change in Vc again is just V in of t. So d V in of t over dt. And this here is the equation for the differentiator circuit. I'm going to just box it up. If you have any questions, please leave them down in the comment section below, and I'll be sure to get back to you. If you like the video, please give it a thumbs up. And if you like what the page is providing, please consider subscribing to it. It really helps the algorithm. Thank you.